Hi everyone. So today we are going to start with the introduction to physics. So I call this series Physics 1.0. What are we going to be talking about here? Talking about elementary physics. So now on that, and that is basically for part one of freshers generally. And so what are we going to be talking about here in Physics 1.01? As I've said, it is elementary or general physics, introductory physics. So this is the first chapter, which I call the introduction. So now, what is physics? Physics is actually the study of matter and energy and relationship between them. It is devoted to the understanding of all natural phenomena. Name any natural phenomenon. You can all study them with physics. Name it the flow of blood in the body, um, galaxies, stars, their formation, even the Earth's rotation around the sun, revolution around the sun rather, and the likes, and many other natural phenomena, things you can see with your naked eyes, you can study with physics. So the study of all natural phenomena generally is what we mean by physics, and it is a very, very versatile subject that as it um, is related to many other subjects, many other science subjects, related to chemistry in some way, mathematics, biology, name it. Even all these other subjects are well known with the help of physics. So the study of natural phenomena, that is physics. Physics is from the Greek word physis, meaning nature. So when we are talking of nature, we are talking of physics. It is the study of energy, matter, space, and time. When we are studying energy, when we are studying matter, when we are studying space and time, we are studying physics generally. Now, the study of physics can be subdivided into two main areas. Yeah, you can classify physics into two main areas, and those two areas are classical physics and modern physics. Now, when we are talking of classical physics, basically, classical physics are the idea of the world that has been known, or better still, let me say that was known before the 20th century. Of course, it is still very much useful today. So, but it was the idea that was known before the 20th century. So, people believe that everything about physics is about this classical physics during that era. And so, when we are talking of classical physics, we are talking of physics of the very large. We are talking of objects that are extremely large and that can move with a speed that is less than the speed of light. So under classical physics, we have classical mechanics, we have thermodynamics, we have electromagnetism, we have optics. Now, a quick definition of each one. When we are talking of classical mechanics, mechanics generally means motion. So when we are talking of mechanics, we are talking of motion. So now when we are talking of classical physics, this is just the motion of large objects moving at a speed that is less than the speed of light. So that's classical mechanics. And now when we are talking of thermodynamics, when we say thermo means heat, and dynamics means motion. So when we are talking of thermodynamics, we are talking of heat, kinetic theory of matter. We are talking of motion. We are so how these things are related. Now, electromagnetism, electro from electricity, and magnetism from magnet. So electromagnetism is just the culmination of electricity and magnetism. It is believed that electricity can be turned to magnetism. And, and magnetism can also electricity can be turned to device in magnets, and that one also can be changed to electricity. So it is believed that electricity and magnetism are one and the same. So the work of people like Maxwell, people like Michael Faraday put this particular branch of physics on a foothold. While optics, on the other hand, is the study of light. So we'll be looking at each one of them later on. So those are just the basic summary of what classical physics is. And now when we are talking of modern physics, modern physics is actually the physics um, after the 20th century. So people used to believe that the whole idea of physics is done and dusted before the 24th century. And so people don't really believe they have any reason to study physics anymore. They believe the laws of thermodynamics has been established and many other things. But when it was in the 20th century, some things began to come up. And so that was what led to the idea of modern physics. Physics after the 20th century, physics of the 20th century and beyond. Let me just see. That's what modern physics is. And so under that, we have relativity and quantum physics. When we are talking of relativity, relativity actually tells us that the world that we know is relative. It also has philosophical implication. For example, if I'm inside a car and to people inside that car, I am stationary. And to people outside that car, I am moving as the car is moving. So relativity on its own is divided into special relativity and general relativity. We are still going to talk about them more. And also quantum physics, which is another study under modern physics. Quantum physics is the physics of the extremely uh, uh, fast objects. Physics of the micro scale, rather. So, physics of the infinitesimally small objects. That is what quantum physics is all about. So, how we can study the world in the micro scale. So, basically, classical physics has to do with the physics of the macro scale, while this quantum physics has to do with the physics of the micro scale. Relativity has to do with object that are physics of objects moving at a speed that is much closer to the speed of light. So that is the idea of relativity. So physics divided into classical physics and modern physics. These are the subdivision of the two uh, division of physics. Now, the holy grail of physics. Physics is a fun subject, and so scientists are working immensely to combine all the four fundamental forces of nature uh, together to form, to be able to predict, uh, to know the beginning of the universe, how, where the idea of dark energy and the likes. And there are also a lot of unsolved problems in physics. And one of those problems was actually the idea of combining the four fundamental forces of nature, how we can combine um, quantum physics with gravity. And so there are some options with that. What part of those options is string theory, and another one is the loop quantum gravity theory. So we believe that when we know when we are able to combine all these fundamental forces of nature, we'll be able to know what happened before the Big Bang, and things like that. So some important feats in physics. Physics is a fun subject, as said earlier on. There are some important feats. There are a lot of feats in physics because, in fact, the basis of modern technology is actually physics. The ISS, which is the International Space Station, is one of those feats in physics. Is the greatest objects made by man that is outside the Earth's surface. We also have the particle accelerator, for example, the one at CERN is also one of the important feats in physics. The atomic bomb that destroyed Hiroshima and Nagasaki and ended the World War was also one of the important feats in physics, and the age of the computer. Those are the important feats in some important feats in physics. There are some also there are many other important feats in physics, but uh, these are some important ones that I will be able to mention here. So, thank you.